Okay, let's try this question again. Sometimes that other method is really makes things much easier, running to a particular place and using the negative exponent to run the money going backwards and stuff. But I think this one's might be easier to do it this way. You don't need to solve an equation, and you can just follow a logical little thing with the amounts as they grow. The first thing, this is a little bit clearer, I think, a way of looking at the timeline. At time zero, it's 50,000. After 1 year, 20,000 is withdrawn. 2 years later, 25,000 is withdrawn, and there's a certain amount left after 4 years that you still owe on the loan. The first 2 years is 0.09% monthly. The last 2 years is 0.09% semi-annually. That's a little clearer for me to see what's going on. Now, watch this. All you do is just grow it the way you see it. You start with 50,000, grow it for 1 year at 9% compounded monthly, and you'll get an amount in your calculator. And then, what are you going to do? Take 20,000, because you're paying 20,000 off on the loan. Subtract 20,000 and grow it for another year until you get right in the middle of that where the interest rate changes. Then take that amount in your calculator and multiply it for another year at 9.5% semi-annually. Then take away 25,000. That's 2 years after you took away 20,000, and grow it for another year semi-annually. See, so it's 1 year is 2, and that's 1 year is 12. And you put that in your calculator, and you get the same answer. That's exactly how much money you'll owe at the end on the loan. That's what X equals. X equals 18,252 Rand and 73 cents. The same way as that other way. And I think for this question, what's the advantage of this method here? There's no need to solve any equation. You don't have to build an equation and solve it. Sometimes it's easier to use the other methods. So anyways, something to think about.